So, good evening, one and all. Now we'll see the topic on block cipher and the data encryption standard. So, which is basically a type of block cipher, which was the standard data encryption technique, which was introduced earlier before all the advanced algorithms which we are using nowadays. But seeing to this DAS, it have the classic encryption technique, which we will discuss in this chapter. So the following are the topics we'll discuss here: the conventional encryption principle, the conventional encryption algorithm, the cipher block modes of operation, location of encryption devices, key distribution. So these are all the topics we'll discuss in this video. And the first topic, conventional encryption principles. An encryption scheme has 5 ingredients, which is plain text encryption algorithm, secret key, ciphertext, and decryption algorithm. The security depends on the secrecy of the key and not the secrecy of the algorithm. So the following is the block diagram of the encryption simplified model, and the conventional encryption, as you see, the plain text has been converted into ciphertext. With when the ciphertext is created, we use a secret key which is shared by the sender and the recipient, and this is the example. The data encryption standard algorithm has been used as an encryption algorithm here, and the transmitted ciphertext has been received at the receiver end, and here the secret key shared by the sender and the recipient is used to decrypt the transmitted ciphertext using the decryption algorithm, that is reverse of encryption algorithm, to retrieve the plain text out of it. And followed by, we can brainstorm the basic concepts of cryptography. The classified along the cryptography, it is classified along 3 independent dimensions: the type of operation used for transforming plain text to ciphertext, and second one is the number of keys used, symmetric key or the asymmetric key. Whereas in asymmetric key we use only single key for the encryption and the decryption process, and whereas in symmetric encryption technique we use 2 keys or public key encryption. One is shared with the sender, shared through the secure channel to the receiver, and one is kept by the sender himself. So the way in which the plain text is processed. So these are all the 3 classified independent dimensions of cryptography. So the modern block cipher involves, will now look at modern block ciphers. So one of the most widely used type of cryptographic algorithm provides secrecy and or authentication services. In particularly, will introduce a data encryption standard, which is also known as DES. Block and stream cipher. So let's see the difference between block cipher and the stream cipher here. So the block cipher process manages into blocks, each of which is then encrypted or decrypted, like substitution on very big characters, like 64 bits or more. Stream cipher process the messages a bit by bit or byte at a time, so when encrypting or decrypting. Many current ciphers are block ciphers, hence we can focus on the block cipher techniques. So the block cipher have the following principles. Most symmetric blocks symmetric block ciphers are based on Feistel cipher structure. So this is needed since must be able to decrypt the ciphertext to recover messages efficiently. Block ciphers looks like extremely large substitution, and it would need a table of 2 power 64 entities for 64 bit of block. Instead, create from smaller building blocks, and using this idea of product cipher. And Claude Shannon and substitution permutation ciphers. So in 1949, Claude Shannon introduced the idea of substitution permutation, that is SP networks. Modern substitution transposition product cipher uses this SP network substitution permutation combination techniques, and these forms the basis of modern block ciphers. SP networks are based on 2 primitives, cryptographic operations we have been before, that is substitution and permutation, S box and P boxes. This provides us confusion and diffusion of messages. So since this will aid in effective encryption and decryption of block ciphers, block cipher substitution technique. Hello all, we'll see the content on confusion and diffusion techniques, which is used in block cipher encryption techniques. So cipher needs to completely obscure statistical property of original message, and for example one time pad does this this effectively. More practically, Shannon suggested combining the elements to obtain the diffusion and confusion pattern, and diffusion dissipates the statistical structure of plain text over bulk of a ciphertext. The confusion makes relationship between ciphertext and key as complex as possible. And so now we'll see about Feistel cipher structure. So Horst Feistel devised the Feistel cipher based on the concept of invertible product cipher. Partitions input block into two halves, processed through multiple rounds, which performs a substitution on left data half, and based on round function of right half and subkey, then have permutation swapping halves. This implements Shannon substitution and permutation network concept. So this is the block diagram of classical Feistel network. So here we can see the blocks given as round 1 to round n. So here in each round, each block, we have the plain text, which is of which is been denoted as plain text, and this has been converted with the F, and the key, which is the sub-generation algorithm, generates the key for K1 from K1 to Kn, and this has been used in this encryption function to create the sub-ciphertext, and this is transmitted to the next block, and that has been there. Again it goes through the encryption function, and this here the separate ki sub key is being generated, and this is being used in the encryption function, and this generates a intermediate ciphertext, and this goes on till ln plus 1 and rn plus 1. So this can go up to around n plus 1, that depends on the number of bits or the length. So generating the ciphertext as a result of this block cipher using this Feistel network. And the Feistel cipher design principle. So block size, key size, number of rounds, subkey generation, round function, fast software encryption or decryption, and easy of analysis. So these are the principles of Feistel cipher design, and this is being shown in this block diagram, which uses the input plain text is being processed through the n rounds of encryption technique, and the output cipher text is being generated. This cipher text from the left is being taken as the input for the decryption technique to generate the desired output. So here this in left, in order to generate the encrypted ciphertext, we have to follow top to bottom technique, and whereas in order to generate the plain text from the ciphertext, we have to follow top to bottom technique, and using the decryption algorithm to retrieve the plain text as using Feistel cipher decryption. And next is data encryption standards, most widely used block cipher in the world, and this is adopted in 1977 by NBS, now NIST, as FIPS pub 46 encrypts 64-bit data using 56-bit key, has widespread use and has been considered controversial over its security. And DES history. So here IBM developed the DES algorithm and used 64-bit of data blocks with 128-bit of key. And IBM submitted their revised Lucifer technique and was eventually accepted by this DES. And DES although the standard is public, and it has also been considered controversy over the design, D has become widely used, and financial, mostly especially in financial applications. And this is the block diagram of DES encryption, which takes a 64-bit and 128-bit. The key is generated, and here permutation and the shift have been used, and the shift swap and permutation, and also the using the generated keys, and again it goes through the encryption function in order to generate the 64-bit cipher text as a result of encryption algorithm. So this is the single round DES algorithm block diagram, which uses 32-bit and 28-bit, 32-bit of plain text and 28-bit of keys. So which results in cipher text of 32 bits. So initial permutation IP. This is the first initial step, and this is left half odd bits to right hand side half, and quite regular in structure, easy in handle. And this example IP which has been given as the encrypted form has been displayed using the encryption DES